Okay, welcome to the first video in Unit 3, Identifying Conic Sections. This is a graphic that you saw in class talking about how you have a double-napped cone and the intersection between that. Here's the double-napped cone, right? It meets together at the apex. And then the intersection of a plane, two-dimensional plane, produces the four conic sections. So, the axis goes through here, apex, element, all of these things are a repeat. The first conic section we'll talk about is the circle. We've used circles before. We've talked about them many times in geometry. We know that a circle has a center point and a radius. The definition is the locus of points. A set of all points is what locus of points means, that are a fixed distance from a common center. So they are exactly the radius all the way around. There's an infinite number of points around the circumference of a circle. The diameter is just 2 times the radius, right here. If you take the circumference and divide it by its diameter, the result is pi. And that's how you get the constant pi. You have the circumference is equal to pi times the diameter. And so the circumference divided by the diameter is pi. The area of a circle, as we all know, the area is pi r squared. The circumference of a circle is 2 times pi times the radius. This last graphic down at the bottom is the unit circle, as you'll recall. Remember that the radius of the circle and the x-coordinate and y-coordinate all make a right triangle from which you can find the length of the radius. That's just a reminder from trig. Okay, these are just fun. I just went on the internet and I Googled it and found all kinds of circles. Even the aliens like circles, but they're crop circles. Pizza, concentric circles or circles within circles. And this was just a neat looking park. Circles are a very pleasing shape. Once again, the aliens really like circles. We like this is used to find depth in here. Of course, a pi. I had to come up with some kind of pi, circumference and diameter. And Venn diagrams, if you'll remember those, where we have a set of A objects, a set of B objects, and then the part where they overlap. All those are done with circles. The standard equation of a circle looks like this: x minus h squared plus y minus k squared equals r squared, where the center of the circle is the point hk. We've seen hk before, have we not? We've used it before. hk is the center, alphabetical. H always goes with x, k always goes with y, and then r is the radius. So you'll notice that to find the radius, you're going to take the square root of that. If the center is at the origin, 0, 0, then this is the standard form of the equation that you would use, this one right here. So if I'm given an example, for instance, x plus 2 squared plus y minus 4 squared equals 36, I know that this is the equation of a circle because I have 2 squared terms and a plus in between them. And then also underneath has the same number. So what you'll do is you will find the center. The center is going to be at negative 2, 4, right? Same number, opposite sign. And then the radius is going to be the square root of 36, which is 6. So of course, to graph a circle, all you need is a center point and the length of the radius. So if I wanted to graph something that looks like this, of course I picked something that was extremely difficult. I would find the center and let's see, 1, 2, 3, 4, 5, 6. So 4.26. And then I would go out 2.4, 2.4, 2.4, 2.4, and draw a circle. And that would get it. If I had another example where I have the center at 0, 0 and a radius of 3, that would be really easier to graph. Put this here and then just go out 3, 2, 3, and draw a circle. And that's how we graph. Okay, so sometimes they give you circle equations in a more general form, and they want you to go ahead and write it in standard form, the x plus h or x minus h squared form. So you're going to have to complete the square twice. So the first thing you want to do on this problem is you want to write all the x values together. I'm going to leave a space, and then the y values together, leave a space, and then I'm going to move the constant to the other side of the equal sign. So you can see here I'm going to subtract the 6 to the other side. Well, this just looks like 2 completing the squares. So I want it to look like this, right, to be in standard form of an equation. So I take half of negative 6 and I get x minus 3, square it, and I have plus 9. Okay, that same plus 9 is going to get added over here to the right side. Now I'm going to do this one, the y. Take half of 2 and get 1. Square the 1, add the 1 to this side. If I add it to one side, I must also add it to the other. I have 10 minus 6, which is 4. And that gives me the equation of a circle in standard form. To graph it, I need two things. I need the center and the radius. The radius is this number, taking the square root. So the square root of 4 is 2. Alright, so I'm going to graph. First thing I need is 2, 3, 1. I need the center. Alright, there's my center. The radius is 2. So I'm going to go out 2 in all 4 directions, up and down, left and right. So I have here's 2, here's 2, here's 2, here's 2, and draw a circle. And that's it. Literally, we are going to complete the square often. So be prepared and learn that skill now because it will come in very handy. Okay, one last thing. I just want to remind you about the word tangent. Here's a circle, not too bad, free-handed. A tangent to a circle is a line that intersects the circle in one point. So this is a line that intersects in one point, just one. If it does 2 points, right, if it goes through like this, this is a secant, and this is a tangent. Okay, then that's literally, it either intersects it or it doesn't. And so you'll either have a tangent, a secant, or a line that doesn't intersect the circle at all. Now here's the interesting thing though. What if it said that the circle was tangent to the x-axis? Right? So here's the x-axis. This is a circle that is tangent to the x-axis. If there was one that was tangent to the y-axis, right? Say here, this would be tangent to the y-axis. Right? So if you know the center of that circle, you will also know what the radius is, right? Because you can count. It'll be this distance will be the radius. And, right, you could count this distance here. So that's what it's talking about. A tangent, if it's tangent to a line, the axes on the Cartesian coordinate plane could also be a line, considered a line. And so that's what that looks like. All right, so we're going to mess with circles in class. You should need everything on here. I hope that when you're taking notes, you're also paying attention to the notes and that you're looking at examples so that when you get to a problem set, you can come back to your examples and see how to work the problem. As always, you want to ask questions in class if there's something in the video that you did not understand. That is your responsibility. So I will see you in class.